Hello, welcome to 3-1 position, velocity, acceleration. This is part B, 3-1 for Essentials of Calculus. We're going to do some examples looking at position, velocity, acceleration, but I got a question for you. Up here on the ledge is Yoda. Hello, Yoda. You seek Yoda. Okay, and I'll ask a couple questions. What is the initial position of Yoda? Well, he's up there. Look, there he is, right there. Okay, and what's his initial velocity? 0. I mean, he has no speed, right? Okay, and I want you to think about it. Think about his position. Think about his velocity, and then what's his acceleration right now? Okay, so just kind of something to think about. Sorry, Yoda, I didn't mean to do that to you. Okay, so let's go ahead and let's dive into these examples here. It says use the position function s of t of an object moving on a horizontal line for examples 2 through 11. Okay, so we have a particle moving on a horizontal line, okay, back and forth. Distance units are measured in feet. This is very, very important. Okay, and time is measured in seconds. Also very important. Okay, so they give us the units. You have to use units, especially in context. Very important. So question 2, what is the initial position of the object? Well, remember position, right, and its initial value is just when t is equal to 0. Okay, so I'm going to take the position, s of t, and I'm going to evaluate at 0. Okay, so I plug in 0, we get 0 minus 0 plus 24, so this is 24 feet. Okay, there is number 2, super easy. Number 3, what is the velocity of the object at t equals 1 second? Well, in order to get the velocity, what we have to do is we have to take the derivative of s of t. Okay, so we're just going to use the power rule here, and what we'll get, 3 times 16 gives us 48 t squared, minus 2 times 36, that's 72 t. Okay, so there is our velocity function, and what we want is t equals 1. So what is v of 1 is what it's asking. Okay, so 48 times 1 squared is 48 minus 72. Okay, and we get negative 24 feet per second. Okay, that's the velocity. So good, right? All right, number 4 and 2. If you're struggling with this, kind of think about. I like to draw on axes, and this is what I want you to do. So here we go. Here we have time, right? And this is in seconds. And then this is our distance, and this is in feet, right? So if I take the derivative of this for velocity, that's feet per second, right? That's the rate of change, feet per second, okay? Number 4, it says, what is the speed of the object at t equals 1? Well, remember that speed is velocity, okay, and it's the absolute value of that. Well, didn't we already calculate this, right? Didn't I already calculate the velocity at 1? Okay, so this is equal to the absolute value of negative 24 feet per second. So this is 24 feet per second. That's the speed per second. Okay, that's the speed of the object. All right, moving right along. Number 5, it says, what is the acceleration of the object at t equals 1 second? So again, okay, I want to calculate acceleration. Well, acceleration, a of t, this is equal to v prime of t. I'm going to go from velocity to acceleration. Okay, so I have to go ahead and use the power rule again. So here is v of t. So 2 times 48, that gives me 96 t. And then minus 72. Okay, so there's our acceleration function, and again, I want a of 1. So I plug this in, and we get 96 minus 72. Okay, and this is going to give us 24 feet per second. Okay, but I need to know, I'm taking the derivative again. So the derivative here, right, this is our position function. I'm looking here. Okay, this is our position function. When I take the rate of change, it's feet over seconds, right? And if I do this again, and what I want to show you up here, I don't know if you can see this board. I'll just bring you with me. Okay, here we go. Okay, so here is the feet over second, right? If I'm taking distance delta y over delta x, okay, and then what I did here is I draw another x and y axis. So this is distance over time. Okay, this is our velocity, so feet per second over seconds. So that makes acceleration distance feet over second squared. Okay, so let me make myself small again, and here we go. Okay, so this is 24 feet per second, or 24 feet per seconds squared. Okay. All right. Number 6. When is the object at rest? Well, our object is at rest when the velocity is equal to 0, okay, when its rate of change is equal to 0. So what we're going to do is we need to calculate, okay, when is v of t equal to 0. So we're going to take our function v of t, which is 48t squared minus 72, and I set it equal to 0. Okay, so we can do this without a calculator. All you have to do is factor out a GCF. So I'm going to take out 24t, leaving behind 2t minus 3 equal to 0. And zero product property tells us 24t is equal to 0, or 2t minus 3 is equal to 0. And we get two answers. We get when t is equal to 0 seconds, and also when t is equal to 3/2 seconds, or a second and a half. Okay, so that's when our object is at rest, when the velocity is 0. All right, number 7. When is the object moving right? Okay, and this is a positive velocity. Okay, so what we want is we want to know, when is our velocity, v of t, when is it greater than 0? Okay, and kind of what we're going to do right now, we're going to kind of do a sine chart. That's supposed to be a straight line. Okay, here is 0. I know the object's not moving, right? We just determined this. Okay, this is when the object's at rest. When else is it at rest? Well, it's at rest at a second and a half. Okay, and I'm going to do a little sign analysis. I'm going to plug in 1. Why not plug in 1? Okay, and I want to go ahead. I'm going to test this, and I'm going to plug it into our velocity formula up here. Okay, so if I plug in 48 times 1 squared minus 72 times 1, right? That's our velocity. Is this greater than or equal to 0? Well, we have 48 minus 72. Is this greater than or equal to 0? And this is clearly false, right? This is not true. Okay, so here we have a negative velocity in this area. Okay, so that means the object's moving left in that time span, and our object is moving right on these areas. Okay, so there you have it. So when is it moving rightward? Well, it's moving to the right when t is less than 0 seconds. What? Time can't be negative. Well, it is here. Okay, or when time is greater than or equal to 3.5 seconds. Okay, there's your answer. It's important to include this in your statement, right? When is the object moving right? Well, I know that the object's moving right when the velocity is positive. Okay, so you got to state that, and then you state your answer. when is the object moving left? So the same idea that we just talked about. I have to state it's moving to the left when the velocity is less than 0. Okay, so I'm going to go ahead and we can use the work that we just did in this example. We said that it's moving to the left between 0 and 3/2. Okay, so 0 is less than t, which is less than 3/2 seconds. Okay, there's your answer. All right, number 9. When is the velocity of the object equal to 54 feet per second? Okay, they want to know when is v of t equal to 54. And what you're going to do here, you need to use a calculator for this one, because v of t is equal to 48t squared minus 72t. Okay, and we set this equal to 54, and we solve. So 48t squared minus 72t minus 54. When is this equal to 0? Or, I mean, you could just plug it into this piece into your function, or into your calculator, and plug this piece into your calculator, and you can see when they're equal. But this does require a calculator. Or if you have a CAS, right, you could just hit solve with the CAS. So there's videos on how to solve those. Look back if you need to. But the answer here would be t is equal to negative 549 seconds. And then also when t is equal to 2.049 seconds. Okay, so that's a calculator problem. All right, number 10. What is the displacement of the object between t equals 0 and t equals 2 seconds? Well, remember, displacement is, okay, what's its current position, and then what was its original position? What's the change, right, between its position? So what we need to do here is we need to calculate, s of 2, and then we need to calculate s of 0. What was the initial starting point? And remember back to problem number 2, right here, we said the initial position was 24 feet. So, I mean, part of this problem is already done for us. I know that the initial position was 24 feet, and now all I'm going to do is I'm just going to calculate the function at 2. Okay, so 16 times 2 cubed, which is 8, minus 36 times 2 squared, which is 4, plus 24. Okay, and I'm going to subtract these, right? So I'll just subtract these two, because that is displacement. Okay, our 24s cancel, and we get 128 minus 144. And this is negative 16 feet. Okay, so that is our displacement. All right, last one, number 11. What is the total distance traveled by the object between t equals 0 and t equals 2 seconds? And again, I'm going to draw you back up to number 7, right? And I want you to see that, that the object changes direction. So t equals 0 starts here, okay, and then it goes leftward for a second and a half. So that's distance, right? That's some distance. And then it's going to change directions and go for another half a second, right, on this way to 2 seconds. So what we need to do total distance, you have to add those two distances up, okay? So what I'm going to do here is I'm going to take the position at 0. We know that this is 24 feet. And then I'm going to calculate the distance. What is s of 3.5? Okay, calculate that, and then I'll say what is the distance at 2? Okay, so I plug in 3.5 into our function, and we get negative 3. Okay, so negative 3 feet. And then I plug in 2 into our function, and we know that this is 8. Okay. So those are our total distance. And then what we want to do is we want to add all of these up, right? So the total distance covered here, right, is 27. And again, how you can calculate that is 24 minus -3. So that is 27 feet. Okay. And then S of 2 here. Sorry, I'm distracted. We have 8 minus -3, and that is 11 feet. Okay, and to find the total, all you're going to do is add these up. Okay, so total displacement is equal to 38 feet. Okay, there you go. All right, so in this video, we talked about actually applying all those vocabulary words that we learned in the past video, and we looked at some examples, okay? Watch the third video for the last set of examples. Catch you next time.